In the last class we have seen that the output of single phase half bridge and full bridge inverters voltages are not sinusoidal. They are their DC component is zero. They are alternating quantities only. That means AC only, but not sinusoidal. AC can be sinusoidal or cannot be sinusoidal. Okay. So now how to find out the sinusoidal component in that? Generally, what is the technique used to find out sinusoidal from any waveform? That is Fourier series analysis. So if you apply that, you will find that V0 is equal to sigma n equal to 135 to infinity 2Vs by n pi sin n omega t. So for getting fundamental component n should be equal to 1. That will be 2Vs by pi sin omega t. Fine. So this n is order of harmonic. And next, coming to the single phase full bridge inverter, it will be double that of the half bridge inverter. Okay, so it will be 4Vs by n pi sin n omega t. These are very important and this is easy to remember. Direct questions will come. Okay, so then what is the load current I0? Suppose if we consider RLC load, most general case, the I0 will be V0 by Zn sin n omega t minus pi n, because as we said there will be some phase difference between voltage and current, and so the divided by impedance will be there. So what is that impedance? If it is RLC load, that will be square root of R square plus n omega L minus 1 by n omega C whole square. This is very simple here. And the phase difference will be, we have discussed in the earlier class also, tan inverse of n omega L minus 1 by n omega C divided by R. So based upon the leading and lagging, it can be plus or minus. Okay, so the load current at the instant of commutation is obtained at omega t equal to pi. Okay, right. Then if you are asked to find out the load power, that is fundamental load power, how will you calculate? It will be V01 I01 into cos pi 1. So you need to consider all fundamental quantities. So these quantities you can get from the Fourier analysis. So what is this V01? Is that maximum or RMS? It will be RMS. So okay, that is important. And otherwise it will be I01 square into capital R. RMS load current of fundamental square into resistance R. So the generally from Fourier series I0 will be equal to Im1 sin omega t or Im2 sin 2 omega t, like that it will be there. And that I01 is RMS, right? So it will be maximum divided by root 2. This is important. Similarly I02 you can get and all. So what about peak load current? Peak load current Im will be square root of Im1 square plus Im2 square plus and so on. Okay, and RMS load current will be as a whole capital Im divided by root 2. Okay, this is for total current, load current. Okay, then that load current total whole square into capital R will become load power, total load power. Okay, fundamental load power is different and total load power is different. Okay, right, this is cool actually. Even I don't know, I came to know this now. Yes, thank you.